Everyone, and welcome to the second practice video for linear speed and angular speed. All right, so here we're just going to solve some problems. Without further ado, let's begin. So first problem, if the arc length of a circle intercepted by the central angle is 123 kilometers and a total time which is length, or this length I mean, is 30 seconds, what will be the linear speed? So we have the arc length of the circle, then the total time you reach this length 30 seconds, and you're asked for the linear speed. So the formula you're going to use here is this one. And why is that? First, you have given arc length of a circle that is intercepted by the central angle, that is 123 kilometers. So that will be your arc length. Then the total time duration, which is the time it reach this length, is 30 seconds. So you are going to use this formula. Plus, you're asked for the linear speed. Okay? So now we can substitute. Okay? So we have 123 kilometers all over 13 seconds. So here, wait, just use my calculator. Wait. This would be approximately, in 2 decimal places, 9.46 kilometers per second. All right, this is your answer. By the way, you can convert any of this unit if you like to, because it's still gonna be correct anyway. Like for example, I want to convert this kilometer into meters. So remember that in your high school days, I do believe 1 kilometer is equivalent to 1,000 meters. Okay, so there are two ways you can convert this one. You can either convert it before you get the answer, which is basically convert this one. Then after you convert it, you can use this to find our answer. Or you can convert kilometers into meters once you get your final answer. So let's do the first one. Like, what if we convert 123 kilometers into meters? All right, so that's okay. So 123 kilometers. So since I told you that 1 kilometer is equivalent to 1,000 meters, okay, you will have a dimensional analysis here, okay? So this one will either become 1 kilometer all over 1,000 meters, or this would be in reverse, 1,000 meters all over 1 kilometers. All right. So the question is, which of these two would be useful? You're looking for the kilometers, right? So, sorry, you're looking for the meters. And the given is in kilometers. So if the given here is a kilometers, then use a fraction that is actually has a kilometer, but it is on the denominator. Okay, why is that? So that we can cancel the kilometers. So let's use this one. So we have 1,000 meters all over 1 kilometers. So we have kilometers here and here, so we can now cancel them. So what's left is we have meters here. So multiply 123 times 1,000 all over 1, we will have 123,000 meters. That's it. All right. This is actually a lesson from your high school, I do believe, which is what you call as the dimensional analysis. This one is very useful if you're going to convert a unit into something else. All right. Just like this one, for instance. Now let's proceed. We can now substitute 123 meters to this one. Okay. So, wait, 123,000 meters. in this formula. So what would be the answer here? So if you're going to use your calculator, divided by 13, right? Yeah, divided by 13. This would be 9,461.54. All right, 9,461.54. All right. You see, this is just kind of a bit far from this. This one's just 9.46, right? But if you're going to use this one, it became 9,461.54. So which one is correct? The answer is that they're still correct. You know, you see, even if it seems like they may be different, but they're actually precise and accurate to the answer. So it is still correct. All right. And by the way, this is the answer. Okay. Let me just erase this one. All right. And if you wish to convert kilometers into meters by using your final answer, you still can. So the same technique, right? We have 9.46 kilometers per second. All right. This one can be rewritten in this way. Just kilometers divided by second. So here, okay, the same thing. Since we have kilometers above, so we will have 1 kilometer below, then 1,000 meters above instead. So cancel the kilometers, then we can now multiply the fraction. So here, the answer, if you're going to multiply 9.46, yes, 9.46 by 1,000, we will have 9,460 meters per second. See? So this one may be almost the same. The difference is the units, okay? And it's also a bit different it's a bit different from our answer last time, which is, I do believe, 9,461.54, right? But still, they're close to the answer. Okay, they're accurate and close to this answer. Okay, so it's up to you if we're going to pick this one, because it doesn't tell you specifically which unit you're going to use. Okay, now let's proceed. If the radius of the circle is 23 kilometers, the central angle is 210 degrees, and the total time it covers this angular distance is 2 minutes, what will be the angular speed? So let's take a look at the given. We have the radius, which is 23 kilometers, central angle, which is 210 degrees. So here you already have the idea that maybe you're going to find the angular speed, right? Maybe. And the total time it covers this angular distance is 2 minutes. Okay. Now, what will be the angular speed? So here, you are now going to find the angular speed of an object. So what would be the formula of the angular speed? So this is W is equal to theta all over T. Theta is the angle, all right? So here, there's no radius here, okay? We only have theta and a time duration. So therefore, we're going to disregard the radius of the circle, okay? And we would rather use this two given. So before we substitute, what's one thing that we need to consider? Right? We have theta. So that means it's an angle, obviously. But I told you that make sure that the angle is in radians. This is not in radians. So you must convert it into radians. So how do you convert a degree to radian? Recall that if you're going to convert a degree to radian, you multiply a number that is in radians by pi all over 180 degrees radians. So multiply it here, you will have pi all over 180 degrees radians. So We can simplify this one. 210 degrees and 180 degrees are both divisible by 30 degrees. So 210 degrees divided by 30 degrees, this is 7. 180 degrees divided by 30 degrees, this is 6. Hence, you have 7 pi all over 6 radians. So that is your angle here. So we will substitute it here. 7 pi all over 6 radians. Now for the time, this is 2 minutes, right? Yeah. Let me erase this one because I'm gonna need some space. So 2 minutes. All right, there we go. So what we can do now is we will simplify this answer. Okay, this is a complicated fraction. So by simplifying it, we will have 7 pi all over 12 radians per minute. And that is our answer. Okay, by the way, if you want to know how I simplified this one, it's like this. I have two fractions, okay, and each of them is on, each of them is on a side of a fraction. So we have a all over b all over c all over d. You see this? They have two fractions here, but this is very complicated, so you have to simplify. So the simplified version of this one is AD all over BC. Let me explain why. You have to multiply outer, or the extremes rather, A and D. So A times D is AD. That is for your numerator. Now for the denominator, multiply the inners, or the means or insides rather. So B times C is BC. So that is how you do it. Okay. Now here, as you can see, we have 7 pi all over 6 all over 2. As you can see, 2 has no what? Denominator. Rather, it is just a whole number. But you see, I remember this one. I think it's the uh, division property. And to be specific, it's an identity property that if we have A, then it's just the same as A all over 1. If we have 2, it's just the same as 2 all over 1. If we have X, it's the same as X all over 1. And lastly, if I have X minus 1, it's just the same as X minus 1 all over 1. So therefore, these two can have an invisible denominator of 1. So we can now simplify this one. Okay, 7 pi times 1 is 7 pi. That will be your numerator. And 6 times 2 is 12. And that's it, guys. Actually, I should have not discussed this because this is actually basic. But to those who have no idea, at least I'm helping you. All right. So yeah, that's the exact answer. However, the problem here is that you need to approximate this one. Okay. So 7 pi divided by 12. Wait, 7 pi divided by 12. This is 1.84. Wait. Yeah. No. 80t. Forgive me. This is approximately 1.83 radians per minute. Okay. So that is our final answer. If you wish to convert a minute into seconds, then it's okay. Remember, the way how you will convert this one is the same way how I convert kilometer to meter. Okay? So it's up to you if you're going to convert one into seconds. All right? So this is our final answer. Let's proceed to the third question. If the radius of the circle is 23 kilometers and the angular speed is 12 pi radians per second, what will be the linear speed? Again, if the radius of the circle is 23 kilometers and the angular speed is 12 pi radians per second, what will be the linear speed? So here, we're going to use this formula. V is equal to R times W. Okay? So this is just basically another formula for you to find the linear speed. So this is the formula of the linear speed if you have the given radius and an angular speed. So according here, your radius of a circle is 23 kilometers. So we have 23 kilometers. Then the angular speed is what? 12 pi radians per second. Okay. So we have this one. Now we can get the answer. So 23 times 12 pi. This is, wait. Okay, good. So this is 276 pi kilometers per second. So that is the exact answer. But we must approximate this one. I think I told you why we need to approximate answers. Okay, it actually depends. Because if we have a pi or a fraction that just say it cannot give you the exact answer, all right, we must learn how to approximate this one, because in reality, if we're asked to find the speed, we would not use this. You get me? Because how would you calculate this one? I mean, how would you measure this one in reality? You couldn't, right? I mean, you could actually, but it will be take a lot of time. So you must learn how to approximate this one. So if you're going to approximate the answer, you will have 867.08. 867.08 kilometers per second. And that is our final answer. All right. So you see, you might be thinking the questions are so easy, right? They are in fact warm up. Okay, they are warm up because we have two questions that are, let's just say, I'm not saying it's hard. Let's just say it will challenge you. Okay, these are the warm ups, you know. So now let's proceed to these questions. Suppose an object moves along the circular path. The object has a total distance traveled of 100 meters, and it reaches 20 minutes to achieve this distance. If the distance between the object and the center of the path is 25 meters, then what will be the first, the linear speed, and second, angular speed? All right. So what are the given? So the object moves along the circular path. All right. So imagine that this is the center, and let's just say the object starts from here, and let's just say it ends at this position. Okay. So the distance between, I mean, at this point, okay, I mean, at this length, or sorry, at this arc, this is the distance. So according here, the total distance traveled is 100 meters. Okay. Plus, you can clearly say that it is an arc length because it moves along the circular path. Okay. If it moves along the circular path, then expect that the total distance traveled is an arc length. So this is an arc length. Okay. Then the time it reaches at that position is 25 minutes. If the distance between the object and the center is 25 meters, which is the radius, by the way, which is the radius, 25 meters. So what would be now the linear speed? So let's start first with the linear speed. I think you already know what to do with this one. So linear speed, you're going to use this formula. So your S is the arc length, remember. So here, your arc length is 100 meters all over. The time it takes to reach that destination is 20 minutes. So to answer that question, this is 5 meters per minute. And that is your answer. Easy. All right. Yeah, that's it. It's easy actually. Okay. And it's up to you if you're going to convert this meter into kilometers. Okay. I already shared to you the technique on how to convert the units. And it's up to you if you're going to convert the minute into seconds. Don't worry. Uh, I have a test video, right? In the test video, I will be having problems that I will ask you to convert into seconds or into different units. Okay. So yeah, that's it. So that is your linear speed, 5 meters per minute. Now, how about the angular speed of the object? Okay, here's the problem. What is the formula of the angular speed? Let me erase this one. It is W is equal to theta on T, right? But you see, we have only one given time, and that is the 20 minutes. All right? However, theta is missing. So what are we going to do? So we're going to use this formula. V is equal to R times W. Why though? Why should we use this formula? Okay. First is that we found already the linear speed of the object. Because the linear speed is, our answer before was 5 meters per minute. Okay. Then the radius is what? 25 meters. So we have two given variables that has a, what do you call this one? A given number. Or basically, speed and radius has a, how should I say this? Has a given. Basically, they're both given. But this one is missing. So we can actually use this formula, okay, to find the angular speed, since uh, two of these variables has, two of these variables have their own given. So let's substitute. Your, what's this again? Your linear speed is 5 meters per minute. Then the radius is 25 meters. Then times W. See? Now all you need to do to find your W is to divide both sides by 25 meters. So what happens? So if you're going to divide this one, this would be canceled. And this one, okay, you will have 1 all over 5 per minute. All right? That is the exact answer, but we have two missing things. One, we must approximate this answer, and two, we will put radians. Okay? So here we will have 0.2 radians per minute. Am I right? Yeah, per minute. Now here's the question. Why I put radians, despite the fact that there's no radians here? Two reasons. First, see, if we're talking about angular distance, it should have an angle, right? We should have an angle. Second reason is that radians is unitless. What does it imply? It implies that it has no units. Radian has no units, okay? And the main reason why we use radian as our representative unit for the angles, because there are angles, once again, that have no, what? Degree unit. So meaning, angles can be represented as just an ordinary number, okay? And those numbers do not have degrees. So we would use radians. Plus, radian is formed when you divide the arc length by the radius. Am I right? So therefore, if we're talking about angles here, okay, just like this one, angular speed, therefore, do not forget to put radians. Okay? Don't forget to put radians as our final answer. If we're talking about angular speed, okay? Do not forget that. All right? So, yeah, that's it. Oh yeah, by the way, another reason why it's unitless, because the unit of the arc length and the radius of the circle are the same. Okay? So, if you're going to divide them, the answer is just, yeah, a number, but it's unitless. But we will represent it as a radian or rad in short. Okay? If it's an angle. And since it's an angle, so we must not forget the radian. So yeah, in other words, just put radians here. Okay? If you're going to use this formula. So that's our answer. Okay? Now let's proceed to the last problem. Suppose a person walked on a circular road. He walked on it a total of 3 rotations within 30 minutes. And the distance between the person and the center of the circle, oh my god, I forgot the word here. Forgive me. It's actually n. Between the person and the center of the circular road is 6 meters. what will be the linear speed of the person when he reaches his final position and angular speed of the person when he reaches his final position. So it seems like it missed something. You get me? It missed something. All right, let's start first with the linear speed. The formula of the linear speed is S all over T, right? But how can we find our arc length if we do not have a given arc length here? Well, the clue is already there. He walked on it in a total of 3 rotations. 3 rotations. So that means, assumingly, this is a person. He walks around a circular path. Okay, that's 1, 2, and 3. That's it. Actually, I'm not sure if it's rotation because for me, I do believe that it's revolution. All right, I think this is revolution, not rotation. Difference between rotation and revolution I test time. Rotation is like, for example, we have this one, an arrow. If you're going to move an arrow here, so it becomes like this, that's a rotation. But revolution, you're here, then it moves around the object or an item in the center. That's the revolution. All right. Or maybe it is rotation. I could be wrong. But I think you get my point overall, the way how I illustrate it or visualize it for you. Now, here's the thing. It rotated 3 times, right? So here's the thing. We know that in one rotation, it's equivalent to how many degrees? 360 degrees, right? By the way, this is the same as revolution, okay? One revolution and one rotation is equivalent to 360 degrees, right? In radians, this is 2 pi radians, okay? So if you're going to have 2 rotations in total, so this is 720 degrees. Or in what's this again? In radians, this is 4 pi radians. All right. So what I'm trying to imply is that if you're going to find the angle in degrees or radians, just multiply it by either 360 or 2 pi radians. Okay. So we have 3 rotation. So multiply 3 to 360, you will have 1080 degrees. Okay. Or in radians, multiplied by 2 pi, we will have 6 pi radians. That's it. Okay, 6 pi radians. All right. So in here, we can clearly see that after he walked in 2 rotations, the angle is 6 pi radians in total. Okay. So now, what's the case here? Case, or why is it important that I include it here? Because I want you guys to find the arc length first, which is S is equal to R times theta. You have the radius, which is 6 meters, the distance between the center of the between the center of the circular road and a person, right? So it's 6 meters. So now all you need is the angle. All right. So you have a radius of 6 meters. Okay. Then times 6 pi radians. So this 36 pi meters. Okay, this is the arc length. It's up to you. You're going to approximate. Then after you approximate, you substitute it here. It's up to you. Okay. But for me, I would rather let it be. I would rather approximate it once we get our final answer here. All right. So with that, we can now substitute. Our arc length is 36 pi meters. Then our t, or time that it reach, time it, let's just say time duration, much better, is 30 minutes. So what would be our answer? So this one, 36 and 30 are both divisible by 3. 36 divided by 3 is 12, and 30 divided by 3 is 10. So we have 12 pi meters all over 10 minutes. Actually, this is also I mean, this is also divisible. I mean, wait, these two numbers are divisible by 2. So 12 divided by 2 is 6, and 10 divided by 2 is 5. So we have 6 pi meters all over 5 minutes. And that is our exact answer. But we must approximate this one. So 6 pi divided by 5, that would be 3.77. Okay? 3.77 meters per minute. And that is our final answer. That's it. Okay, that's how you get your linear speed. Okay, so 3.77 meters per minute. All right, let me take a look if I'm correct, if I'm wrong or correct. Okay, good, good. So that's it. Now let's find the angular speed of the person when he reached his final position. Okay, so now let me erase this one. Okay, let me erase this. So the formula of the angular speed is W is equal to theta all over T. So remember the angle we found out, right? In 3 rotations, we will have what? 6 pi radians. So we can substitute this one in this formula. So we will have 6 pi radians. Now for the time is 30 minutes. So let's now simplify. These two numbers are divisible by 6. So 6 divided by 6 is 1. And 30 divided by 6 is 5. Am I right? Yeah, good. So that would be pi all over 5 radians per minute. And we're done. All we need to do now is to, what I call this one, is to, yeah, what's that again? Approximate. Yeah, there we go. So the approximate answer for this one is pi divided by 5 is 0.83. Oh, wait, no. 83? 63. So 0.63 radians per minute. And that is our final answer. And yay, we're done. Okay? We're done with our practice videos for the linear speed. With that, you can now proceed watching this video. All right? Which is I uploaded the test one, right? So yeah, good luck with that, guys. Okay? So see you soon.